So I wanted to show you a little about messing around with some data for this experiment. I set up the Excel spreadsheet with our day of germination over here in the first column A, and then I didn't do all 7 other concentrations like you might, but just wanted to sort of give you an idea of what it might look like to do a range of concentrations. So I listed them by percentage of sodium chloride up here, and then just created some fictitious data for each of these. All right. After that, went ahead and went into Excel and asked to create a scatter plot. And after coming up with titles and messing around with where I put the legend and such, ended up with a sample data sheet here. That looks something like this. And so what's nice about it is, we have our legend up here that tells us which solution concentration the mung bean were subjected to, and we can start to see that there's a trend here. And if I had to sort of look at that quickly, it seems like the higher the salt concentration, the less growth in that radical. So here was our 3% salt, and here was our 2% salt, and here is our 1%, and there was our control, our 0% salt. What's nice, since it is a graph, is you should be able to quantify the effect of the salt concentrations. So think about what you would compare your various test concentrations to. And if we can compare them to the control, and that's the purpose of control, then we'd say, okay, so what fraction or what percent of growth did it see relative to the control? Assume the control is 100% growth, and therefore we have less than 100% growth in our 1%. One way to use Excel to help you do this is to actually have it create the trend lines for this. So let's see if I can do this right. If I click on my data set and I come up here to, I come here to chart, and then down here to trend line, and a trend line for that. And definitely has a linear look to this. I would expect, at least as the days went along, it should look more linear. So we'll let it be a linear type here for the graph. So that looks good. In options, I can actually have it do a little work for me. I can certainly do a little algebra and do the slope equation for this, or I can ask it to display the equation here. So if I ask it to display the equation for that line, it's going to give me at the spot here. So the slope of the line is 0.5 times x. So 0.5x is our slope. And now I say, okay, well, how does my experimental here for the 1% compare? So let's try that again. Sort of hover on one of the samples and click on it. So now I'm choosing all this data set here for 1%. Again, up here to chart and add a trend line. And again, we want to display the equation on the chart. So it tells me the slope here is 0.3486. Well, that's a lot. That's a mouthful. But let's just call it maybe 0.35. So the slope here is 0.5. The slope in this one is 0.35. How could I then figure out what is the percentage, the rate for our red line? So I'll let you think about that for a second. So after thinking about it, we had our 0.35 here and a 0.5 there. Make it simple, we can think of that as like 3.5 and 5, or maybe double it and say at 7 and 10. So the slope of this line is 70% of the slope of our control. If we think about it, it's 30% less growth per day. So in terms of the overall concept, if we have 30% less growth at 1% concentration, then definitely be suffering the effects of salinization. Anything that has a decrease by 10% or more would be a salinization effect. But to continue that process, you'd want to then compare the others as well. So again, one more time, if you do this, click on it. Oh, let's go back. What if you don't have? What if you're maybe using one of the other graphing programs? Best fit line for these. Now, I wish I could do this for you some simple way, and I don't know a simple way of doing this, but to add a best fit line here, I could get a straight edge ruler out, and I would sort of line that straight edge ruler out. And sort of the rule of thumb is, well, we want as many of these points touching the line as possible. So in terms of our little triangles here for our 2%, as many of those points on the line that I could get. If I can't get them all on the line, then I want to sort of use my ruler so that as many points can be, but for those that can't, I'd want an equal number above the line as below the line. So to sort of average out the slope of the line by having some of the data be above and some of the data be below the slope that I can draw with my ruler. So then I'd use that ruler to sort of scribe a line that would sort of come up across here so that, again, as many of them are possible. I'm not going to curve it, but rather trying to find the slope, I want to sort of do that. Another possibility to do is just for the slope is to take any of these 2 points that look like they're probably linear and then just use your slope formula for that. So maybe here at day 1 and slope formula here at day 6, and use that to calculate the rate of change between day 1 and day 6. So you got a bunch of options. If I again use Excel to do it for me, we add our trend line and display that on the graph. And so this is even an even more gentle slope, therefore even further away from our control line in terms of the growth per day. So we can start to use Excel to do this for us if we really need.